So we mentioned previously that given a known vector, magnitude and direction, sometimes it's useful to break up that vector into its components. And that's especially useful when we have to add or subtract vectors. So what does it look like when we add or subtract a vector? Well, we combine the use of components along with the use of unit vectors. So remember that the unit vector for vector v was vx I hat, so that just indicated the x component of the vector v, and I hat indicated that it was in the x direction. And vyj hat was just the y component of v in the j direction, or the y direction. Alright, so for instance, with vector v, we could say that this vector here is 3 I hat plus 4 j hat. Alright, and then w, remember the x component of w is not -7, it's -2 I hat plus 2 j hat. Alright, so another thing we could do is we could add, combine like terms. So for instance, we can combine all the I hat terms and all the j hat terms. So that would look something like this. Vx, so the x component of v, I hat, plus the x component of w, I hat, plus the y component of v, j hat, and the y component of w, j hat. Alright, and then we could factor out those terms and make this a little bit cleaner to look at. So we could say vx plus wx, factor out the I hat, plus vy plus wy, factoring out the j hat. So a little bit neater. And here in typed, it looks a lot neater than my handwriting. So we could also say that the resultant vector, if we add v and w, we can call it, say, u. And so u would just have x components of vx plus wx, and the y component would similarly have the vy plus wy. Alright, so what does this look like graphically? So one thing to keep in mind when you're adding or subtracting vectors is we say that we add them from head to tail. So remember that the head of a vector is the tip of the arrow, right, that part there, and the tail is the other end. Alright, so here I've added vector v and w, and we got a resultant vector u. Alright, so the resultant vector, we draw the tail of the resultant vector starting at the tail of the first vector, and then we draw the head of the resultant vector at the head of the final vector. Alright, so that gives us our what we call resultant vector. So if we look at the x component of u, vx is 3 and wx is 2. And actually that's -2, remember, because it's going to the left. And so that gives us 1. And the y component of v was 4. And the y component of w is 2, so that gives us 6. So we could write this as vector u is 1 I hat plus 6 j hat. Alright, then if we look at that resultant vector, we could see that, yes indeed, where I drew it, it is 1 I hat, is 1 unit in that positive x direction, and it's going up 6 j hat. Alright, and so then we could apply trig, we could find what exactly that resultant vector is, and we could find the angle, the direction of that vector. Okay, so one use for adding and subtracting vectors would be to add or subtract or find an object's displacement. So let's look at a situation here where we have an object that moved in 3 different times, and we want to find out what's the resultant of that. So let's say the green vector here, we'll call that vector A. Let's call the blue vector vector B, the purple vector vector C, and then the resultant vector, we can call that vector G. So this could be, let's say it's Daisy. She moves one time in vector A, then another time vector B, another time vector C. She ends up at some point. So she didn't follow a straight line, so the displacement that she has is going to be different than the total distance that she traveled. So it doesn't matter how many vectors we add up, it's all the same thing. We just add the x components, add the y components, and that gives us our resultant vector. So for vector D, the x component is the x component of A plus the x component of B plus the x component of C. All right, so A, the tail started at 6, the head ended up at 4, so the total x component is -2. So -2 because we moved from 6 to 4. We moved toward the negative direction. Then vector B, we're starting off at 4, ending up at 0, so -4. And then C from 0 to -6. So that gives us a total of -12. Then again, the y component of D, it's just the y component of A, the y component of B, and the y component of C. So the tail of A starts at 2 on the y-axis, goes up to 6, so that's 4, +4. B goes from +6 to +8, so 2. And then C is nice and easy. It's just all completely along the x-axis, so it's a 0 for the y components. So our y is just 6. So then we can write this displacement as -12 I hat plus 6 j hat. And then if we wanted to, we can go ahead and apply trigonometry. We can find what the actual magnitude is of this vector and what its exact direction is in degrees. Another situation you may encounter is something like a boat traveling down a river and it's got a current kind of blowing it off its course a little bit. So let's say that we have a boat here. It's represented by vector v, and let's say vector v is representing the velocity of the boat. So if we just use cardinal directions, we can say maybe the river runs north-south along the y-axis. And the x-axis would be our east-west. So we see here that the boat is moving perfectly along the x-axis, making it nice and easy for us. And the length of the vector is telling us -10, right? It starts up here at 10 on the y-axis and it ends up at 0, so that's just saying the magnitude is -10, right? It's pointing in the negative y direction. So we could say that the magnitude of v is 10, maybe let's say miles per hour. Maybe it's knots or something, whatever they use on boats. Okay, and then the direction, we could just say maybe it's just south, all right? Because we said our coordinate system represents the cardinal coordinates. So now let's say there's a wind blowing, and it's blowing the boat toward the east. So maybe there's an easterly wind of 3 miles per hour. So I'll just pick a random spot here on the graph to represent the 3. So it's 3 units on the grid long. That's how long the vector is to represent the 3 miles per hour. Let's call this just vector W. And it's pointing directly to the right along the positive x-axis because it's moving straight to the east. All right, so if we want to add these two vectors, graphically, remember we add them from head to tail. So I would add that vector right here at -6. It would end up in -3. Okay, add the tail, and then we draw the resultant vector by the tail of that resultant vector starts at the tail of the first vector, okay? and the head ends up at the head of the second vector. Alright, so we call that our resultant vector u. So to find our resultant vector, again, we add up the x components, add up the y components. So the x components of u, right, are the x components of v plus the x component of w. So what is the x component of vector v? Well, if we look at it, it's at -6 the whole time. So its x component is 0. Alright, it's going just straight along the y-axis. Alright, the x component of w, we start at -6, end up at -3. It's moving in the positive x direction, so that's just a positive 3. Alright, so our x component of u is 3. Then our y components, so our y component of u is going to be y component of v plus the y component of w. Alright, the y component of v, remember, is -10. And the y component of w, remember, it's only in that x plane, so it doesn't have any y component, 0. So the y component of u is -10. So we can write this in unit vector notation as u is 3 I hat minus 10 j hats. Alright, so just one note on 3 dimensions. We're not really going to do a whole lot of 3 dimensions here in this course, but you might come up with them in the future. So just to mention them, so with 2 directions, we represent objects in a coordinate plane usually, with the x direction being that axis, the y direction being that axis, but the z direction, all right, remember that's what creates our 3rd dimension. And so again, they would all cross at the origin there, but instead of it going on the screen there, whatever you're looking at in your phone, your tablet, your computer screen, your monitor, that would be, if you were looking at it like that, it would be more of going into or out of your monitor. All right, so maybe into the monitor is positive, out of it is negative. All right, so that's really kind of gets complex to represent. You have to really beef up your drawing skills to try to represent that. So in a unit vector form, we have x direction is I hat, the y direction is j hat, the z direction we call k hat. I know it doesn't need a dot there, right? K doesn't have a dot. All right, so that's just how you would represent that, and we're not really going to do a whole lot with that right now.